Hello, everyone, and welcome. So my name is Patrick Bolton, and today I'll be talking to you about the 400 megahertz band award in Ireland, or as some people know it as the Smart Grid Spectrum Award. I'm joined by Dr. Samuel Ritchie, who on this project fulfilled his role as Spectrum Advisor to the Commission, and I myself was Project Manager on this project. So today I'll be speaking to you about the reservation for spectrum for smart grid. So I'll cover what the 400 megahertz band is and its availability, what ComReg decided to do in relation to the band and smart grids, and also how ComReg did it. So what materials we used and what resources we came across in our consultation process. So the 400 megahertz band is on screen, as you can see. It goes from 410 to 414, paired with 420 to 424. So it's quite a small amount of spectrum, 8 megahertz in total, but we offered it as 2 by 4 megahertz. The band was also unused at the time when we began our consultation process. So this all began with ComReg's Radio Spectrum Management Strategy Statement for the years 2016 to 2018, in which submissions to this document pointed at the potential value of the spectrum. And ComReg also noted that there were a number of potential uses for the band, and we obligated ourselves to commence a consultation process on same. So in July 2017, we had our first consultation published on the band. And this consultation at a high level examined the potential uses of the band, and we invited industry to comment on same. So you can see the four main potential uses that we listed in this band at the time. There were smart grid, smart metering, digital mobile radio or private mobile radio, and public protection and disaster relief. And there was good engagement with this consultation. We got 12 responses, and so ComReg considered that that was sufficient justification to further examine the band. So it was at this point we commissioned Plum Consulting London to do three things for us. The first one was to analyse the potential uses of the band. The second one was to assess the amount of spectrum that may be required for each of those potential uses, the availability of alternative frequency bands or solutions for those potential uses, and also the future availability of those alternative frequency bands or solutions. And then the third thing we asked them to do was to assess the technical requirements that may be needed to provide for those uses. So Plum, in its report, they looked at the broad potential uses of private mobile radio, public protection and disaster relief, mobile networks and fixed wireless access, smart grids, and also smart meters. So this is the second time in these slides that I've separated out smart grids and smart meters as being different potential uses. And that was because for the purposes of this consultation process, ComReg considered them to be two separate uses. So we based our definition on Plum's definition, which was in turn based on the ITU definition of smart grid, which was a term used for advanced delivery systems for utility services, electricity, gas and water, from sources of generation and production to key elements in the grid networks, and includes all supervisory and control necessary for their effective management. So whereas we defined smart meters as the devices located at premises which measure the utility services and allow for a two-way communication between it and the grid. And you'll see in the following slides that, as well as the definition being different, there was a good reason for it because of technological differences also, and available solutions for each potential use. So a summary of Plum's findings is here. So you can see essentially they looked at spectrum requirements first, and they ensured that each of the potential uses could actually fit in and possibly make use of our available spectrum of 2 by 4 megahertz. And as you can see, every potential use fulfilled that filter. Then they looked at whether there was an identified demand for this potential use. So in the case of private mobile radio, Plum was of the opinion that there is not, as it has many other spectrum bands available to cater for these services. In terms of smart meters at the bottom of the table, Plum were of the opinion that no, there was not identified demand, and that was because there are other solutions available, such as services for mobile network operators and short-range devices. With regards to public protection and disaster relief, Plum said that there may be a future requirement for broadband PPDR, but they noted that there are other spectrum bands available also. And for mobile networks and fixed wireless access, they were of the opinion that yes, there is a demand, but mobile networks have plenty of spectrum available to them already. And they also noted the upcoming 5G auctions, where they would have a chance to gain far more spectrum than what was available or on offer here. So the story was different with smart grids. As you can see, it fitted into the small amount of spectrum that we had available, with 2 by 3 megahertz being required. In terms of identified demand, Plum was of the opinion that yes, there is a need for it. And with regards to other bands or solutions being available, Plum noted that there is likely no other suitable bands or solutions available. Because of the nature of smart grid, it was deemed that sub 1 gigahertz spectrum is required to achieve connections to remote locations. And whilst most of the sub 1 gigahertz spectrum is used by MNOs, digital television, etc., they did note that 450 to 470 may be suitable, as it has been, wideband solutions have been deployed in those bands in other countries. However, this is not the case in Ireland, as this band is heavily used for business radio or private mobile radio type applications. Plum further noted that you could use scanning telemetry for the control and monitoring, but that these could not support requirements for changes to supply networks within the grid. So, following on from the Plum report, ComReg then started looking at international developments and noted the following that are on screen in relation to smart grid. So we noted that within ITU, there was work ongoing on an ITU recommendation 2351, and as part of that, CEPT FM54 had proposed a revision to that recommendation, specifying that 2 by 3 megahertz of spectrum is required in the 400 megahertz band for the provision of smart grids. With regards to ETSI, the technical standards body, we noted a technical report, TR 103401, and there was also a work item identifying the future requirements for smart grids, and that smart grids were necessary to meet Europe's need for the reliable provision of utilities. And ETSI also stated that 2 by 3 megahertz of spectrum is required in the 400 megahertz band. With regard then to the CEPT, ComReg noted that what was then a draft decision and has since been adopted, ECC decision 1902, it specified the least restrictive technical conditions for narrowband and wideband land mobile systems that operated in a number of frequency ranges, including our 400 megahertz. And so what this indicates to ComReg is that there would likely be equipment availability in the near future. So at this point in the consultation process, we came to our regulatory impact assessment, or RIA, as we call it. So RIA is essentially, it's an analysis of the likely effects of a proposed new regulation or regulatory change, and indeed of whether regulation is necessary at all. A RIA should help identify the most effective and least burdensome regulatory option, and should seek to establish whether a proposed regulation or regulatory change is likely to achieve the desired objectives. And it looks at all of these things through the lenses of stakeholders, competition, and consumers. So we noted the important policy issues arose out of the Plum report and the recent international developments, and they're listed at the bottom of the slide there. So the first one was, is there a likely requirement for smart grids in Ireland? And the second was, are there alternative solutions that could deliver a smart grid? So with regards to the first question of, is there a likely requirement for smart grids in Ireland? We started looking into international bodies, and we noted that the ITU and the UN both state that smart grids can help to mitigate climate change, and they have documentation on that. And we also noted that there was a wealth of international studies on smart grids and the benefits of same. I have two examples here on the screen. The Electrical Power Research Institute said that a smart grid-enabled electrical distribution systems could reduce electrical energy consumption by 5 to 10%. And the Sustainable Energy Authority of Ireland stated that by 2050, smart grids will see an accumulated reduction in energy-related CO2 emissions of 250 million tonnes. Looking then at the European Commission, we found that they have a directive from 2009 which encourages member states to modernise the distribution networks, such as through the introduction of smart grids. And we also noted they have a policy framework for climate and energy in the period from 2020 to 2030, in which it again encouraged member states to further develop their policy frameworks and introduce smart grids. Closer to home, then, we noted that the Government of Ireland had released a number of documents in which smart grids were mentioned, one of which was the National Energy and Climate Plan, where it noted that smart grids are one of the key measures required in order for Ireland to meet its climate emissions goals. And also it was mentioned in the National Development Plan, which is part of a greater plan called the Project Ireland 2040, as you can see in the picture on the left. And that observed that smart operation of the power system at both transmission and distribution level and energy efficiency will enable maximisation of our existing grid. So it seems from all of this material that there was likely a requirement for smart grids within Ireland. So that led us on to our second question of whether there are alternative solutions that could deliver a smart grid. So for this, we again referred back to the Plum report, and we referred to work done by the CEPT on smart grids. And we noted that a smart grid requires low to medium data rates or multiple megabits if video is required. They need a 10 to 20 year lifetime. They must be highly resilient. They need to have extensive geographic coverage with low latency, and they need to be highly secure. So we first looked at whether telemetry systems could be a viable alternative solution, but we noted that they do not provide enough control for smart grid, and they do not support they do not have the bandwidth requirements necessary to support smart grid. In terms of then mobile networks, we noted that ETSI is of the opinion that mobile networks, they would require a resilience and power backup upgrades to provide for smart grid. And they also were unlikely to provide the geographic coverage, reliability, resiliency, or latency needed for a smart grid network. Further, we also noted that ETSI stated that a smart grid should be self-owned or managed, and that the spectrum should remain under the control of the utility. So at this point, still within our RIA framework, we decided that ComReg had three options available to it to divide up the available spectrum for a potential award. Option one, you can see on the screen, was to reserve 2 by 3 megahertz for smart grid, and we call that part A. And then we would then offer the last 2 by 1 megahertz of spectrum in small 2 by 100 kilohertz lots on a technology and service neutral basis. And so we call that part B. Option two was to offer the whole band on a technology and service neutral basis. And option three was to reserve the whole band for smart grid use. So then, looking at all these options under the lens of stakeholders, competition and consumers, ComReg noted that reserving some spectrum for network utility operators is preferred, as it allows other technologies and bidders access to the remaining part B spectrum, or 2 by 1 megahertz of spectrum. And it also allows a network utility operator to potentially use and bid for the 2 by 1 megahertz for other services to either accompany smart grid or complement smart grid. It also reduces the possibility of a network utility operator not winning any spectrum, option one. And we noted that mobile network operators were unlikely to be interested in the band, as it was a small amount of spectrum and there's little to no mobile handsets compatible. In terms of competition, ComReg noted that under option two, so if we were to award the band, all of the band on a technology and service neutral basis, there was a risk that a network utility operator may not win the spectrum and may be forced into using suboptimal alternatives. So you may recall that ETSI said the spectrum should be owned and operated by the network utility operator. And it could also end up in leasing the spectrum from another winning bidder, which would distort the auction process and create much higher prices and exclude certain bidders. In terms of consumers, then, ComReg noted that consumers would likely benefit from the introduction of smart grid, as it would reduce power outages, likely put downward pressure on energy prices, and it would also lower carbon emissions. So you recall that this was the band that we started out with 2 or 3 years previous when we began this consultation process. And then this was the proposed breakdown for the spectrum awards. So you can see we went with option 1. Part A was for smart grid, 2 by 3 megahertz, with part B being made available on a technology and service neutral basis. So for part A, in order to participate in the auction, you needed to be a network utility operator. We were offering licenses of 15 years. And if we did not get any applicants for this piece of spectrum, we would break Part A down into 2 by 100 kilohertz lots and include it in the Part B award on a technology and service neutral basis. The fee for Part A, the reserve price, was 240,000, and it had annual fees of 39,000. Part B then, it was also a 15-year license with a reserve price of 8,000 per lot and annual fees of 1,300. So the results then of the award process was that ESB Networks DAC acquired the whole band, which, if you are a supporter of smart grid, was a very good outcome. So for further reading, if you want to know anything further about what I've spoken about here, you can do so. You can find it on ComReg's website is the top link, and we have a 400 megahertz band award page that lists all the documents that were published and when. And I've also listed the 3 most important documents at the bottom of this slide, which is the decision, the information memorandum, which will detail all the rules and the procedures around the award process, and finally also the results of the Spectrum Award. So thank you very much for your attention. Myself and Dr. Samuel Ritchie will now take any questions you may have. Thank you.